Hi, my name is Ming Tse Chen, and in this video, I will walk you through my causal analysis project on student performance. This notebook explores how different educational factors actually cause differences in student outcomes, moving beyond correlation into true causal inference. So, um, before I begin, let me briefly introduce what this notebook is about. In this project, I explore how different educational factors like test preparation, parental education, and economic advantage causally affect student performance. I don't just look at correlations. Instead, I apply proper causal inference methods like matching, regression, and propensity scoring. Through this notebook, I aim to show how thoughtful data preparation and causal reasoning can lead to more accurate, fair, and actionable insights, especially in education. This work can help guide smarter interventions and policies that are actually grounded in cause and effect, not just surface level trends. So first, in this section, I first explain why causality is important, especially in education. We want to know, for example, does completing a test prep course actually improve scores, or are those students already stronger? I introduced the difference between correlation and causation, explain common sources of bias like confounding and selection bias, and talk about causal tools like directed uh, acyclic graphs and the potential outcomes framework. The key idea is we want to estimate what would have happened to a student if they hadn't received a treatment like test prep, even though we only observe one outcome per student. Next, I load and explore the dataset. It's a rich dataset of 1,000 students, which variables like parental education, test prep completion, gender, and scores, scores across math, reading, and writing. I check for missing values, none found, so that's good. I also create two new columns, total score and average score, which I will use as outcome variables in my analysis. This section is all about understanding the raw data and getting it ready for deeper causal modeling. Here I perform a deeper inspection of the data. I show counts of categorical variables and how many students are in each test prep group or a lunch program. I also highlight that things like lunch type can serve as a proxy for economic advantage, a likely confounder. This helps me later when I decide which covariate to control for. In this step, I create key binary variables. For example, I convert parental level of education into binary variable indicating high parental education. I also define whether students completed the test prep course and whether they are economically advantaged based on lunch type. And lastly, I calculate the average score and define my treatment variables for causal estimation. Now I begin estimating causal effects using nearest neighbor matching. I match students who did not complete test prep to similar students who did, based on covariates like parental education, economic status, and gender. The results show that students who completed test prep scored, on average, about 7.66 points higher, uh, 7.66 points higher, even after accounting for these other variables. This is a key insight, suggesting that the prep course itself likely caused the boost. I also compared these results to naive difference in means. Without adjustment, the difference was around 10 points. So, after matching, the treatment effect is still strong, but slightly smaller. This shows that confounding was present and matching helped control for it. I include a scatter plot that shows treated and control units in feature space. Here. This helps visualize how well the matching worked. It confirms that I'm comparing students who are similar across other variables, except, uh, except for the treatment. Here I switch to second method, propensity score analysis. I estimate each student's probability of completing test prep using logistic regression and use inverse probability weighting to balance the groups. Then I compute the weighted average treatment effect. The result again shows a strong positive effect from test preparation, which supports my earlier findings. I also plot the distribution of propensity scores for both groups to show that overlap is reasonable. This is called the region of common support. Next, I examine whether parental education causes better students' performance. I use both regression and matching here as well. Both methods show a positive effect. Students whose parents have higher education levels tend to tend to perform better on average. But again, I try to isolate whether this causes better scores rather than being a confounded association. Here I summarize and visualize all the causal effects I've estimated using clean down here using cleaned labeled plots to compare treatments and control groups for test prep, parental education, and economic advantage. These visuals make the findings easy to interpret, even for a non-technical audience. This section asks, do these treatments affect all subjects equally? I look separately at math, reading, and writing scores, and for each, I estimate naive and adjusted treatment effects. And interestingly, I find that some treatments help more in reading and writing than math. For example, test prep has a stronger causal effect on reading than math. This helps target interventions for more precisely. So, to wrap up, this notebook shows how thoughtful data preparation and causal inference can help us move from correlation to causation. By using methods like matching, regression, and propensity scores, I showed that test prep, parental education, and economic advantage all causally influence student performance. This is powerful for educators and policymakers who want to build evidence-based strategies, not just rely on observational patterns. At the end, I list the data source from Kaggle and mention that this project is shared under an open license for reuse and learning. Yep. Thank you for watching my crash course in causality. I hope this gives you insights into how we can use data science to uncover meaningful, actionable causal relationship in education. Yep. Thank you.